to prove that root 5 is an irrational number. So first, before we prove that it is an irrational, let me assume that root 5 is a rational number, the converse of it. If it's rational, then there exist two integers r and s such that root 5 equal to r divided by s. Root 5 equal to r divided by s, where s is not equal to 0. If r and s have a common factor other than 1, and then if we divide by the common factor, let root 5 equal to a by b, where a and b are co-primes. So therefore, if root 5 equal to a by b, I can write this as root 5 into b equal to a. Squaring on both the sides, I would have 5b square equal to a square. So here, therefore, 5 divides, since 5 is a factor of a square, I can say that 5 divides a square. So according to the previous theorem we have learned, we can say that according to the theorem, if 5 divides a square, 5 divides a. Now we can write that a equal to 5 into c, since 5 divides a, where c is some integer. Now if I square this on both the sides, squaring, I would have a square equal to 25 c square. Now here, previously in the equation 1, I have a square equal to 5b square. So I will replace here. So I will write 5b square equal to 25 c square, b square equal to 5 c square. Now here 5 divides b square. Therefore 5 divides b. But here you can see that 5 divides a square and 5 divides a, and 5 divides b square, and therefore 5 divides b. So you can observe that the common factor in between a and b here is 5. But we've already assumed that that a and b are co-primes. Here we have a contradiction. Since this is a contradiction, we can simply say that root 5 is an irrational number. A and b have common factor 5, but we already assume that a, b are co-primes. Therefore, root 5 is irrational. Since it's a contradiction. Please take a screenshot of the solution and please subscribe to our channel for more updates.